Okay, this video is going to be the part 2 for section 2.1, which is the area between two curves. So what they want us to do here is they'd like us to find the area bounded by the functions f of x equals the sine of x and g of x equals the cosine x from x equals 0 to x equals 2 pi. Again, it's important to draw a rough sketch of what's going on. Okay, so we got our y-axis and our x-axis. Okay, and so the maximum of both sine and cosine is 1, and then the minimum is going to be minus 1, so we'll want to go from 1 to minus 1 on the y-axis, and then the period of both sine and cosine is going to be 2 pi, so we're going to want to go from 0 to 2 pi, and that's also what they're asking us to integrate from, is 0 to 2 pi. And going by 90 degrees or pi over 2 in radians is going to be nice for graphing this. So we're going to go 0 is already there at the origin, pi over 2, pi, 3 pi over 2, and then 2 pi. And then we can just read these values right off the unit circle. The sine is going to be the y-coordinates, and the cosine is going to be the x-coordinates. Okay, so the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is back to 0. And so there is the sine graph there. Okay, and then we're going to go ahead and graph the cosine. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0, and the cosine of 2 pi is 1. Okay, and so we're going to find the area. So there's a piece right there on the far left there. Okay, and if we look at that one there, the upper function is the cosine function, and the lower function is the sine. Now, when you get into the next region over here, then the sine becomes the upper function and the cosine is the lower function. And then finally in the last region over here, the cosine becomes the upper function again and the sine is the lower function. So if we have this change in upper and lower functions, that's going to require some more integrals. Okay, so we're going to need an integral for the first piece there, and I've drawn in a representative rectangle. So we're going to need to find the limits of integration. So we know one of them is 0, but what is this right here? And so to find that, we need to figure out where the sine and the cosine intersect each other. Okay, so where does the sine intersect the cosine? Well, that's going to happen infinitely many places. However, we're restricted to 0 to 2 pi, which is the unit circle. So if you notice on your unit circle that the sine and the cosine of pi over 4 are both root 2 over 2, and the sine and the cosine of 5 pi over 4 are both negative root 2 over 2. And so on the unit circle, pi over 4 and 5 pi over 4 are going to be where these two functions intersect. Okay, if you want more intersections, just add multiples of really pi to pi over 4. Positive or negative multiples to pi. So anyways, so the first intersection we have there is going to be at pi over 4. Okay, and then the other intersection is going to be 5 pi over 4. So that sets up us with our limits of integration. So for the first one there, it's going to be the integral from 0 to pi over 4. Upper function is cosine, and the lower function is the sine, integrating with respect to x. Okay, plus, we're going to go on to the next region, so we'll go ahead and highlight that. Draw in a representative rectangle. I might have done that afterwards. So the limits of integration here are going to go from pi over 4 to 5 pi over 4. That's the start and the end of this region. Okay, so here I draw the representative rectangle. That just kind of helps me with what's the upper function and what's the lower function. So the upper function is the sine and the lower function is the cosine. So sine minus the cosine is going to tell us the area of that, not the area, but the height of that rectangle. Okay, and then finally the last portion there, we'll go ahead and do a little bit of a highlight. We're going to go from 5 pi over 4 to 2 pi, okay? And we'll draw a representative rectangle in to kind of help us with the upper and the lower functions. The upper function is the cosine, and the lower function is the sine. Typically, the hard part is getting it set up. Once you have it set up, then it's going to be, usually it's going to be routine integration, calculus 1 type of integration. So we'll go ahead and do that on the next page here. Okay. So we'll just go ahead and rewrite all that right there. So that's what we had on the last page there. Okay. And so now we're ready to integrate. So we're going to do that first integral. The integral of cosine is sine. And the integral of minus sine is positive cosine. And that's going to be evaluated from 0 to pi over 4. Plus the integral, or the antiderivative of sine, is minus cosine. And the antiderivative or integral of negative cosine is negative sine. And then we're going to evaluate that from pi over 4 to 5 pi over 4. And then finally, the last one, the integral of cosine is sine. Integral of minus sine is cosine. And then we're going to evaluate that from 5 pi over 4 to 2 pi. So the first integral that we're evaluating is going to be the sine of pi over 4 plus the cosine of pi over 4 minus the sine of 0 plus the cosine of 0. So as we stated earlier, both the sine and the cosine of pi over 4 are going to be root 2 over 2. The sine of 0 is 0, and the cosine of 0 is 1, so we're going to have a minus 1 there. And root 2 over 2 plus root 2 over 2 is going to be root 2. Okay, well, let's go ahead and do the second one. So minus cosine of 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus the sine of pi over 4. Okay. All right, so cosine and sine of 5 pi over 4 are going to be negative root 2 over 2. Because it's minus cosine and minus sine, that's going to have a double negative. It's going to make them positive root 2 over 2. So we'll go ahead and write the double negatives here. Okay. Okay, and then the next one, I got a minus sign here, but I went ahead and distributed it to those, both the cosine and the sine, so those signs will offset. Sine and cosine of pi over 4 are going to be root 2 over 2. Okay, so we have 4 root 2's over 2, so that's going to be 2 root 2. Okay, and then finally the last one, the sine of 2 pi plus the cosine of 2 pi minus the sine of 5 pi over 4 plus the cosine of 5 pi over 4. Okay. All right, so the sine of 2 pi is going to be 0. The cosine of 2 pi is 1. Okay, and then both the sine and the cosine are going to be negative root 2 over 2, and then, well, that's not a very good 2. There's a little bit of better one. Then we're going to apply that minus sign to it, so it's going to make them positive. So they'll both be positive root 2 over 2. So that's going to be root 2 plus 1. Okay, and so to find the area between the sine and the cosine, from 0 to 2 pi is going to be the sum of these three integrals. So we've worked out kind of the evaluating each integral separately, so now we just add them all together. So the area is going to be root 2 minus 1 plus 2 root 2 plus root 2 plus 1, which is going to be equal to 4 root 2. So the exact solution's fine, or decimal approximation 5.659, and then again that's going to be units squared. Okay. So stay tuned for the third part of section 2.1, and there we'll be doing integration with respect to y. So instead of having an upper function and a lower function, and functions being in terms of x, we're going to have a right function and a left function, and we're going to be integrating with respect to y. So we'll see you next time.